Good evening. My name is Anouar Majid. I'm the founding director of the Tangier Global Forum. I'm associated with the University of New England in other ways. And I know this talk tonight is being watched in the United States live. And we have the ability to do that thanks to my colleagues in the back. Maybe in other European countries, Spain, France, if they're watching us, hola, and bonsoir, and maybe in other parts of Morocco, I don't know. So I just want to welcome you all to this event. It should be a very interesting event. And I just wanted particularly to make note of the presence of a very old and dear friend of mine, Mustafa Kalai, who is in the back, and Mohammed Simsamani there as well. We are, really, it's a pleasure to see them among us tonight. Do you understand what I'm saying, or should I translate very quickly into Teresa? Teresa? Okay, it's Organic. So we do have a simultaneous translation going on into Arabic, and I've asked Professor Lindee to speak very slowly so that the translator would be able to catch up to what she's saying. And then if you have any questions, you can then ask at the end in any language of your preference. So I am extremely, extremely happy to bring to you tonight Professor Susan Lindee. To me, it is truly a huge accomplishment because Susan is a historian of science at the University of Pennsylvania, one of the best institutions in the United States, and who studies historical and contemporary questions raised by human and medical genetics, science in the Cold War, nuclear weapons, and radiation genetics. These are kinds of topics that she really deals with as a historian, which is a specialty that is extremely rare and highly specialized and very interesting. She is Janice and Julian Betts Burst Professor in the History of Science. Her books include Suffering Made Real, published in 1994, The DNA Mystique, published in 1995, and with the late sociologist Dorothy Nelkin, she published the DNA Mystique with her, and Moments of Truth in Genetic Medicine, published in 2005. Lindee also has been involved in collaborations with anthropologists, including her work with Alan Goodman and Deborah Heath on the 2003 edited volume called Genetic Nature, Culture, Anthropology and Science Beyond the Two-Culture Divide, and her April 2012 co-edited special issue of Current Anthropology, The Biological Anthropology of Living Human Populations, World Histories, National Styles, and International Networks. In fall 2014, she was a visiting professor at Hiroshima University. Lindee is a Guggenheim Fellow, a Weyler Fellow, and the winner of the Burroughs Wellcome Fund 40th Anniversary Award. And she is also a Schumann Prize. She has a Schumann Prize of the History of Science Society. So she has a lot of she's got a lot of accolades and a lot of recognition from a variety of places. She's currently working on a book called Rational Fog, A History of Science, Technology, and War. What I'm trying to say is that she is working at the intersection of science, human nature, politics, and society. And so her presentation today, which is one of the most famous ones that she gives, but she also gives a lot of other things on nuclear histories and all that, is part of this kind of work that she does. So please help me welcome Susan to the podium.
Thank you for that lovely welcome, and it's really great to be here in Tangier. It's an interesting place, and I've already met some wonderfully interesting people. Best-selling book in his own lifetime was a book about earthworms, and for this book, Darwin returned to a topic that had fascinated him as a child. By this time, when it was published in 1882, he was a 73-year-old famous scientist, world-renowned scientist, and he spent several years roaming around the British countryside looking for worms at Stonehenge and on the farms of his friends and neighbors, and also calculating how long it had taken for the action only of worms to bury Roman roads in the British countryside. This book was seemingly about a trivial subject, that is worms, but I open with it in order to suggest that it was a book that captured the core insights of Darwin's life and his scientific thinking. And that core insight is the powerful potential impact of very small events that take place over a very long time. And so at one point he says, it may be doubted whether there are many other animals which have played so important a part in the history of the world as have these lowly organized creatures, speaking of earthworms. But what he's telling us as he studies them is that even tiny things operating over a long period of time can transform the world. And that's really what evolution by natural selection is about, tiny changes over long time. Now, his project captured the public imagination. He was kind of ridiculed for it. This is a Punch illustration in 1882, which shows him tangled up with monkeys and worms. Man is but a worm. But it was an important book for him, and a book that established the legitimacy of his kind of arguments. Evolution by natural selection, which is Darwin's real contribution to our understanding, its natural selection, is one of the most misunderstood ideas in the history of science. Many of those who originally embraced Darwin's theory in the 19th century didn't really understand it. They rejected natural selection. Many of those later who questioned the theory not based on its scientific insights, but on its social or moral or political implications. So the things that made it most important for us today when we look at it, those things were not necessarily what people noticed about the theory on the first round. Today, I'm going to give you some insights into what the theory actually proposes, what was Darwin saying in his writings and in his ideas, and also a little bit of insight into the long-term unfolding legacies of the theory, the ways people thought about it later, and the ways that it, and the reasons that it became so controversial. And really, quite frankly, there is still controversy around the theory of evolution by natural selection. So Darwin came up with this idea, and it's had a long afterlife and a powerful afterlife. I also want to tell you a little bit about Darwin himself, and here's the truth. Historians who work on Darwin, and I teach Darwin and Darwin's work, we all come to love him. People start to think of him as almost a family member. He was a very kind person. You read his correspondence. He was a kind of a sweetheart, and he was always trying to help other people, and he was modest. And so you start to get almost a crush on Charles Darwin if you work on him long enough. And I want to capture some of that charming quality that he had, because I think it was important too for the arc of his scientific career. One thing that he did very well was to establish and sustain long-term social networks that became resources for him as he needed to understand given problems. And that's a very important, that was partly because of these social skills that he had. Now, to say that he didn't discover evolution is an understatement. There had been theories of evolution since his own grandfather had a theory of evolution in the 1790s. Many thinkers had come up with ideas about change over time that indicated historical or genealogical relationships between plants and animals, between different species, and in the overall population of animals and plants everywhere in the world. Fossil discoveries suggested this could be true. There were studies of biogeography, analyses of predator-prey relationships, which suggested that these relationships were very tightly calibrated so that neither the prey nor the predator died out, so there was some kind of a balance going on. All of these things seem to suggest that the natural world, the living world, had some kind of historical relationships, possibly genealogical. Erasmus's theory, and this is his grandfather, he never knew his grandfather. Erasmus's theory was more vague, but there was also someone who published when Darwin was a toddler, and that was the great French natural philosopher Jean-Baptiste Lamarck. And Lamarck had a fairly elaborate and sophisticated notion about evolution, which said that animals change over time based on the needs that their environments produce. So an animal that needs to have a longer neck will desire that longer neck and will eventually get it. And by the time that Darwin was a practicing scientist, Lamarck was something of a joke in Europe, and Darwin saw his work as a refutation and an anti-Lamarckian approach to evolution. If you know anything about contemporary epigenetics, you know that Lamarck is enjoying something of a renaissance in the sense that Lamarckian ideas have a certain resonance with epigenetics, which modern epigenetics shows that environments have an impact on which genes are expressed, turned off or on. We can talk about that later if you want. So who is actually the real discoverer of the real processes of evolution could change. We could begin to view Lamarck as our key genius. Students encountering Darwin for the first time, and I have them read The Origin, they're often astonished by the power and the clarity of his argument. His explanation, which he called, of the process he called modification by descent. He did not use the word evolution until the 5th edition of The Origin. It is a book that is indeed one long argument. And when students first encounter it, you can see his mind. You can see the way he thinks unfolding on the text. He presents his evidence. He shows what's wrong with his evidence. He tells you why he's concluded that he's right. So he's a very powerful and systematic thinker, and in my eyes, a very compelling writer. One has the feeling of being in the presence of a devoted teacher or, a great thinker. But the book is also an account of a community, a time, a place, a social class, an imperial system. It is not just about Darwin. Throughout his text, Darwin refers to dozens of other people, to other natural philosophers, but also to the breeders he spoke with, to people he encountered in his 5-year voyage on the HMS Beagle. He was always consulting pigeon breeders. He tried to breed pigeons for a while because artificial selection is such an important way of understanding natural selection. He corresponded with scientists and even social theorists all over Britain and Europe and a wide network of naturalists. He read social theory. And so my point here is that Darwin's genius was nurtured in Victorian Britain, and it was made possible by both his wealth and his masculinity. Gender is a part of his story. He was privileged in that he was groomed for certain kinds of positions and opportunities. And his father he never had a paying job. No one ever paid Darwin to do anything. His father paid for him to go on the voyage of the Beagle, and for the rest of his life, as he came into certain forms of inheritance, his life was devoted to science and to managing his finances. So there's privilege automatically that makes it possible for him to have no set of duties, although this was a person who worked obsessively his entire life. He never stopped, continued writing books, continued doing science. So who was he? This is the young Darwin. He was born in February 1809, and if you want to picture his childhood, picture an average Jane Austen novel. It was in Shrewsbury, and he was born to a respectable family. It was a village northwest of Birmingham, not far from the Welsh border. He was the 5th child and the 2nd son of a prosperous medical doctor and his wife, Susanna Wedgwood. Susanna, his mother, was the heir to the Wedgwood fortune. This is Wedgwood pottery. His grandfather had been a scientist and an evolutionist. His mother died probably of cancer when he was 8 years old. In his autobiography published late in life, he said he didn't remember her or her death. Her place was taken by 3 devoted older sisters who apparently cared for him with great affection. Now, the two grandfathers he never met mattered a lot in his life, and I'll just tell you a little bit about these two grandfathers. The first I've already mentioned, Erasmus Darwin. Erasmus Darwin was, like the entire Darwin family and Darwin networks, an anti-slavery thinker. He was a product of the Enlightenment. He played an important role in the Industrial Revolution in Britain, and he also wrote about evolution and about the love life, about the plants, about botany. And so he published his own theory of evolution. It was sort of a vague account that talked about sexual selection and competition as powerful in biological systems. It's not that it was intellectually important for Darwin, but the stature of Erasmus played a role in Darwin's easy entry into scientific circles in Britain. The other grandfather matters in a very different way, and this is Hosea Wedgwood. He was the entrepreneur and industrialist who built a significant fortune. The Wedgwood fortune was what permitted Darwin to have the financial freedom that meant he never had to work and that he could pursue his science. So this gentlemanly social standing, manufacturing affluence, and also the religious skepticism, it's not so important early in his life when he begins on a path toward becoming basically a country parson. That didn't work out. He didn't become a country parson. But later in his life, the courage that it took for Darwin to decide, as he explicitly did in 1871, to bring human beings into the story of evolution. That's the scary part about evolution. Remember, from the beginning, even harsh critics, as long as you kept humans out of it, it wasn't so hard to take, if it was just plants and animals. But what Darwin was proposing, he had to be something of an independent thinker about religion to choose to do that in Britain at the time. So the young Darwin was supposed to become a physician like his father and his grandfather. And he was sent off to Edinburgh Medical School to be a student. In the early 19th century, surgery was undertaken without any form of anesthesia. The young Darwin witnessed his first surgical procedure and announced that he did not want to be a physician. It was not for him, the medical career. So his father was very disappointed with him and said, you'll be a failure, you'll be a disgrace to your own family. How can you do this to us? Typical things fathers say. But Darwin then, as a kind of a poor second, went off to Cambridge to study to be basically a theologian. So he's either going to be a physician or a pastor, and the backup plan was to be the pastor. He had a great 3 years at Cambridge, and in fact, Cambridge is what made him a scientist. The culture of theological interest in the natural world was very powerful in Britain at the time, and many of his professors were in fact also naturalists of one kind or another. It was common for the preacher to also look at nature, because nature was the place where the mind of God was made explicit, where you could see the beauty of God's wishes and God's desires. So when he went off to Cambridge, he spent 3 years. He was doing a lot of collecting of animals, a lot of field geologizing. It became kind of a hobby with him. And he also, as a Cambridge student of theology, read a book that affected him very deeply, and this was William Paley's Natural Theology. Natural theology was a movement in the late 18th and early 19th centuries that was oriented around the idea that you could prove the existence of God by looking at the natural world. And the image you may know the best is of the watchmaker. It's the idea, and this was Paley's analogy, it's the idea that if you were walking in the woods and you encountered a watch, by virtue of its clear utility and its complexity, you would reach the conclusion that it had been made for that purpose by someone. And so the natural theologians, and there were a lot of them, there are many, many books, the Bridgewater Treatises, all written about this. The natural theologians said, if you want to prove that God exists, look at the complexity of nature, and in nature, the mind of God is made manifest. And it's proof of the existence of God. When Darwin read this, he was completely persuaded. He thought that, and Paley is fun to read, in fact. He's an interesting thinker. One of the great things about Paley is that he saw the ecological relationships between organisms that we take for granted. But it was a very early form, almost of ecological thinking. He was struggling with why did predators have enough to eat? Why didn't they just kill everything? Why did prey survive despite all the foxes? And so at one point in the text, he says this famous quote, suppose I encounter a watch on the road. The watch must have had a watchmaker. There must have existed, or at some time or some place, an artificer who formed it for the purpose we find it to answer. And so Darwin loved this book. It definitely influenced him as he moved out into the field, and he thought about ways of looking at nature and the field. There's one other influence I'm going to mention, and this is someone who became his very dear friend, Charles Lyell. And so Paley gave him a way to think ecologically about plants and animals. Lyell gave him what we call deep time. Many of his contemporaries would have believed that the earth was not very old. And when Darwin first began to look at the natural things he saw on the voyage of the Beagle, he was not worried, in a sense, about deep time. But as he developed his theory of evolution, it could not work unless there were long periods of time in which these very, very gradual changes could occur. And he first read Lyell's theories about geology when he got onto the Beagle in 1831. Lyell was basically saying the geological processes that we see today in actual time are the same as those that existed in the past. So this was called uniformitarianism. Many geologists had taken the position that there had been a time in the past when there were lots of volcanoes and dramatic geological events, and Lyell said, no, it just takes a long time for mountains to rise, and anything can happen if you have enough time. This was very important for Darwin. So he read Lyell as he headed out on the voyage of the Beagle in 1831. He was actually invited to join the Beagle by Captain Fitzroy, not because he needed a naturalist, but because he needed a gentleman. And Fitzroy had a rough crew with him. He wanted to have someone who could have dinner with him and could have sophisticated intellectual discussions. Darwin was not his first choice, and indeed, Darwin was it was a professor at Cambridge who he was really interested in. Darwin got offered as a second choice. Darwin's father didn't want him to go, thought it would be a disaster, and then his uncle persuaded the father to pay for the trip, and Darwin left on the HMS Beagle. There was no official naturalist. This was a mapping project for the coast of South America, so he was not appointed as a naturalist, but he turned it into that. He made himself the naturalist of the HMS Beagle, and almost immediately he began sending materials, ideas, texts back to his friends in Britain, who began to write about them, donate them to museums, produce papers based on what Darwin was seeing on this incredible voyage, so that by the time he got back, and it was supposed to be a 2 to 4 year voyage, and it took 5 years. By the time he got back, he was a famous naturalist, and there was no more talk of him going into the clergy. There was no more talk of any other career except to be a naturalist and a scientist, and he had several publications to his name. So instead of ruining Darwin's standing, the voyage of the Beagle really made his life and his career. I highly recommend reading his diary-like account of his adventures on the voyage of the Beagle. I read it when I was about 14 years old, and I think then I knew I wanted to be a historian of science. It was such an incredible voyage. When Darwin returned to Britain, he he traveled very little for the rest of his life. He never came to the United States. People invited him, and every now and then in a letter you can find something like, oh, it would be interesting to see the United States, but he never came. He barely traveled around Britain. He had some kind of an digestive disorder. There's been a lot of speculation about what he had. But he commonly used his digestive system to get out of going to meetings, to dinners, to parties. So because he wrote so many letters, we know how many invitations he turned down. He was happy to stay at home and happy to use that time to write and to do science, which is really what he did. But the sheer volume and range of all that he saw on the trip was incredible. And I want to talk a little bit about the voyage of the Beagle. He paid attention to plants, to animals, geology, coral reefs, tides, winds, fossils. And I want to use the verb inhaled, which may not translate very well, but when you read the way that he approached it, it's like everything he encountered, he was asking questions about. He inhaled this experience, and it was such a powerful experience for him. He was not always sure what he was seeing. He was seeing it, recording it. He didn't know what it meant. So, for example, when he went to the Galapagos, this is one of his famous case studies, he collected finches on every island, and he just threw them all in the same bag without labeling which island they were from. It turned out that understanding which island each different finch was from was important for his theory. And he was able later, when he finally figured out he'd made a mistake, he was able to reconstruct it based on his notes and testimony from people on the islands who told him how the finches differed from island to island. So this is somebody out in the field collecting data, but not yet sure what he's doing. What is he collecting it for? The trip also shaped his understandings of human variation, and for Darwin, honestly, the trip was as much about encountering different kinds of people from those he would have met in his British world in an incredible way. So he met all kinds of people all over the world, but the starting point was his voyage with the Tierra del Fuegians, who had been brought to Britain to be civilized, would have been the verb that would be used at the time. They were taught English, taught to dress like the British did, taught to eat and drink like the British did. And the Tierra del Fuegians were being sent back to Tierra del Fuego on the Beagle with Darwin in order to be missionaries, the civilizing mission, but also the Christianity mission. So they were Christianized, and these Tierra del Fuego, one of them was named Jemmy Button, they were supposed to come back to their homeland and persuade their people to become Christians. He was struck by the fact that Jemmy Button acted in every way like a proper British gentleman. And when he encountered Tierra del Fuegians on their island, this is a small island at the very tip of the bottom of South America, the difference between these natives he encountered and Jemmy Button struck him as proof of the power of culture. There was nothing biological about the differences between the Tierra del Fuegians and the British. It was strictly a matter of what they had been taught, what practices they had adopted as a culture. And so this is the beginning of his efforts to come to terms with racial difference. Remember, too, that right at this moment, Britain is engaged in a fairly elaborate debate about eliminating slavery in the British colonial empire. Slavery was banned in Britain itself in 1807 or 1809, but in the 1830s, as Darwin left on this trip, there was an ongoing debate about what to do about the fact that slavery was still such an important part of the imperial economy. More or less successful, and so Britain is playing in some ways a leadership role in this global debate about this economic system. Britain was still supplying the slave guns for the slave trade. So remember, virtually all the slave guns which animated and drove the slave trade in Africa were made in either Birmingham or Manchester. These were cheap, inexpensive rifles for use in battle. They had an impact on tribal warfare, on intergroup tensions in Africa itself, and they justified African participation in the slave trade. So Britain is still benefiting from the slave trade in the 1830s, but Darwin is a part of this debate, and it's a part of the ways that he looked at the people he encountered. Could you justify slavery based on some presumed biological difference between the Brits and anyone else? And he does not believe so. He also found the attitudes of slave owners. He met, I want to mention this, he met with Maoris, with Patagonians, with Tahitians, Aborigines in Australia. He rode for months across the Pampas in South America with the Gauchos. And the Gauchos were mostly mestizos. They were of mixed European and indigenous heritage. So he was with people of many different kinds all through this trip, and he had a kind of broad interest and enthusiasm about them. At one point he said all humans were brothers. They all had rights and dignities. He and Fitzroy had one of their worst fights over this very issue. They were invited to dinner at a plantation in Brazil, and the Brazilian plantation owner called in his slaves for the evening and said, "Are you happy?" And the slaves all said they were. And when they got back to the boat, Fitzroy said, "See, that proves it. They're really happy being slaves." And Darwin didn't think that. He thought perhaps their answer was forced. And so they had a row about this. This led to a row. Now, by the time Darwin returned to Britain, he was already a famous naturalist, as I said, but his theory was not quite assembled. He was struggling to make sense of what he had seen, and he was filling up the famous transmutation notebooks. And the transmutation notebooks were a series of colored notebooks where he's beginning to try to decide what the things has seen might tell him. Sometime in early 1837, he drew this very famous tree, I think. There are people who have this tattooed on their back. This is like an incredibly powerful image in the history of evolutionary theory. He says there's an original point. He's got little notes about what the relationships are between these different kinds of species. And he wrote in this same notebook that he thought that new species could originate without divine agency. He's getting rid of God in 1837. He also said that evolution had taken place not just on the Galapagos Islands. His first round of evidence was the Galapagos Islands. Not just on the Galapagos Islands, but everywhere. And not just among plants and animals, but among humans. Already, 1837, he's expanded it to every living thing, and it's all over the world. So this was a powerful idea. And in these notebooks, he also first makes explicit, and we have to assume he'd already been thinking about it, but he first makes explicit the connection between artificial selection and natural selection. He was talking to breeders. He was interested in the ways that breeders could transform a dog or a horse or cattle. But he starts to say artificial selection is a model or an analogy, or it is similar to natural selection, and we know how powerful it is. And in the end, when you actually read The Origin, artificial selection plays a huge role in the argument. He invokes it over and over again. Even though in artificial selection there is a purpose, there's a goal in artificial selection. So what you've got to believe in natural selection is that it could happen without a goal. The next crucial thread for the theory came in September 1838, and we know that because we have his notes and we have his notebooks, and that's when he read the political economist Thomas Robert Malthus's essay on populations. Many of you might know Malthusian population theory, and what Malthus said basically was that there was a natural tendency for human beings to increase at an exponential rate. And the fact that the number of human beings born increased exponentially, but things like famines, wars, disease, epidemics, and he also mentioned infanticide, kept human populations in check. Now, in Malthus's account, these checks on human populations were all to the good. So it was a way of keeping human beings from becoming too numerous and having insufficient resources to survive. And indeed, in Malthus's vision, those who were most likely to die of disease or lack of access to food were probably the ones who should die. That is, the poor, infants, women, people without power were the ones who really were expendable in his account. So it was evidence for him of a proper political order. The most vulnerable people were those most likely to die and most dispensable. It wasn't a critique of this fact. But Darwin thought about Malthusian mathematics and applied it to natural animal populations, which only a moment's thought helps you can recognize that if mice were not checked in some way, we would be 8 feet deep in mice right now or all the time. So why aren't we 8 feet deep in mice or rabbits or any rapidly breeding small mammals? And there are lots of them. And so Malthus gave him a way of thinking about what is checking the increase in any population, what keeps a population from rising. And if that process of checking, and this is his initial word, checking, if that process tended to favor those with certain advantages, and even if those advantages were relatively trivial, but the checking occurs against 5 million mice, even a small trivial difference could have statistically an impact on the mouse population. So small differences over the long haul, over large numbers of individuals, could accumulate to produce fundamental change over deep time. That's the great, so he gets this insight really in 1838. He began to see it all. He didn't use the word struggle for existence. Those came from Herbert Spencer later. But this is what he begins to see, the struggle for existence. It's an engine for change. Organisms become more suited to their conditions of existence, to their environments, to their whatever they're competing with, because of what he now calls natural selection. And he began to work it out analytically and talk it over with his friends. He began to write it up. He sent a paper around asking people for commentary. Did this seem plausible to them? What was wrong with the theory? And right in the middle of this, he watched in horror, as a popular book, Vestiges of the Natural History of Creation, provoked a public outcry in which evolution, and particularly human evolution, was debated and criticized. And so Darwin is watching, this book it was an anonymous book. It was written by Robert Chambers, who was an Edinburgh popular science writer, but when it was published anonymously. And some people hypothesized that the great naturalist Charles Darwin had written Vestiges of the Natural History of Creation. Chambers proposed an evolutionary theory that people were inside of. He was very controversial, and Darwin is watching this. This is the kind of book that if your mother found you reading it, she might throw it in the fire. So this was a really scandalous book at the time. He's watching this debate and he's trying to figure out how can he learn from it what the reactions are likely to be to his own work. And it helped him anticipate the objections to his theory, and it helped him understand what the public outcry would be like. Meanwhile, and right about this time, he wrote up a complete paper about his theory. He wrote about 30 pages outlining evolution by natural selection. He put it in a drawer in his desk at Down House. He put it in an envelope, and he wrote a note to his wife, Emma, that said, "Publish this after I die." So he was so afraid of publishing his theory of evolution by natural selection that he decided he wasn't going to do it right away. He may have been concerned, in fact, about Emma's feelings because the theory would imply that human beings were not created by God. And so he had married his cousin Emma Wedgwood just after he returned from the voyage of the Beagle. Together they had 10 children, 3 of whom died in infancy or childhood, but it was apparently a happy marriage. Emma, however, was extraordinarily religious, extraordinarily devout, and go back to the microphone. Am I too far? Where do I need to be? Okay. So she was extraordinarily devout, and he may have been concerned about how Emma would respond to this paper and this idea. Meanwhile, over the next 20 years, and yes, you heard it right, the paper sat in the drawer for 20 years. No scientist could do that today and get tenure. Over the next 20 years, he published 4 exhaustive volumes on the classification of barnacles. The great Charles Darwin spent many years hunched over a variety of barnacles, writing about barnacles. He also published on many other topics. He looked at volcanic islands. He did a book on coral reefs. He published the Voyage of the Beagle. He published on geology. So he's a very active scientist in this 20 years. But the great insight that we will remember him most for is sitting in that drawer at Down House in Britain. Now, in June of 1858, disaster struck. And the disaster was Alfred Russel Wallace. Alfred Russel Wallace was a collector, and he was then in the East Indies. He was collecting in Malaysia and Singapore and Indonesia. And as things turned out, Wallace had also read Thomas Malthus's essay on checks on population. And he came to the exact same conclusion as Darwin, that something like natural selection was implicated in the evolution, in natural evolution. He wrote up his paper, and he sent the paper to Darwin saying, who he knew, they had corresponded. He said, "Great naturalist, do you think this paper is worthy of publication?" So Darwin panicked. He sent the paper around to all his friends who'd already read his paper, and the compromise solution was that both of the papers be read together this is June of 1858, that they both be read together in July of 1858. Neither author was there. Darwin had lost a 19-month-old son 3 days before, and he was home in mourning, and Wallace didn't even know that the papers were being read. But the papers were read, and over the next year, and one of the accounts of the meeting, this was a meeting of the Linnaean Society, the minutes of the Linnaean Society said nothing important happened at the meeting, which means probably that when these were read, nobody quite realized what these theories might lead to. So the following year, in 1859, Darwin published his book-length elaboration of the argument, and this was on the origin of species by means of natural selection, or the preservation of favored species in the struggle for life. It was one of the greatest scientific books ever written. He proposed a disturbing mechanism for change over time, and I'm going to kind of quickly go through some of these very detailed PowerPoints. We can return to any of these questions, but his mechanism, the key thing that you need to realize is that, first of all, the mechanism involves mass murder. That is, millions of creatures had to die in order for anything to happen as a result of evolution. So it's a gruesome and brutal world. It's not William Paley's divinely ordered world of balance and everything as it should be. It's survival of the fittest. It also, and equally disturbing, it has no goal. In Darwin's conception, evolution's not going anywhere. It's not heading to human beings. It's not heading to intelligence or anything. It's going nowhere. It has no intention. So it's a very upsetting idea, and Darwin himself was upset. It depended, to say this was a shocking thing to have to say. And he also presented a range of evidence. And again, we can return to these, but basically morphology, which is body type, embryology, development, vestigial organs, his observation that everything varied, and in the book he carefully goes through all these ways that everything varies. Geographical distribution, so for example, there were relationships between fossil forms in a given location and living forms, which suggested a historical relationship. And this fossil record suggesting links between ancient and living creatures. He could show that individual plants varied from each other ever so slightly. Even mice could be found to vary, and he didn't know how or why variation occurred, but he knew that it happened. He could document what breeders knew. They knew that if you had a large population of sheep, you could select from the sheep certain individuals who would be more likely to produce a given outcome. So artificial selection also plays a huge role in the origin of species. He's got a huge single chapter about it, and it's in many other chapters. He could cite geographical distribution, and I have a PowerPoint, and he could point out that habits and structures don't always agree. The grebe is a completely aquatic bird, but its feet are not fully webbed. They're partially webbed. That's evidence of evolution, evidence of the ways that an organism can change. And then the fossil record, this is really here because Archaeopteryx is my favorite fossil because it's a fossilized bird. But he was interested in what fossils could tell us about evolutionary change over time, and he laid out his evidence in great detail, beautifully explaining why each bit of data mattered. But he also laid out in the origins all the problems with his theory. He addressed them in a very straightforward way. So he says, where does variation come from? Is it from the environment? Is it chance? Why aren't all mice the same? Is there a direction? Is it goal-directed in any way? Is it moving somehow? And then intermediate forms. And when he says to this day, the eye gives me a cold shudder, what he means is that it's very difficult to understand how something as complicated as the eye, which has multiple layers of systems, that is, you need the eye mechanism, you need the brain, you need the connections between them. How do you get all that at once out of mutation or out of small gradual change? So he doesn't quite know how to do it. He doesn't know how to get from mammals to whales. How do you get land-dwelling mammals that then turn into things that swim? So there's a lot he doesn't know, and he admits this in the book, the things he's confused about. Most importantly, Darwin had no idea why variation occurred. And this is what really undermined him and led him to, in some ways, abandon the core of his theory. He came up with a theory that you've never heard of, and that's because it's one of his least successful ones, and that is pangenesis. So Darwin noticed that organisms were so well calibrated for their environment, and he wondered if there was something in the blood, which he called a gemule, that could travel around and collect data and bring that data back to the germ cells so that the next generation knew that whatever was needed, the germ cells could be transformed to match the environment. And so he doesn't know he doesn't know anything about DNA. He doesn't have any sense of molecular biology. No one does. So Darwin is working in the dark. Worst of all, he accepted the idea of, he's got pangenesis, but worst of all, he also accepted blending inheritance. And blending inheritance says the next generation will always be half paternal, half maternal, and what that meant is that any new property would quickly be swamped. So he published 6 heavily revised editions. He used survival of fittest only in 1869 and evolution in 1872, but basically he became more and more Lamarckian as things went on. In 1871, he published Descent of Man and Selection in Relation to Sex, which put man into the story of evolution. This is T.H. Huxley's famous image, which here is a morphological similarity between the great apes and the human skeleton. And Darwin's theory had a long and contested history after his death. And I'm going to turn to that now. There's a lot more I could say about Darwin, but I want to at least get to this final phase of his theory, the meanings of his theory. The forces that were anti-Darwin came together in some ways in the 1925 Scopes trial in Dayton, Tennessee. And John T. Scopes was a biology teacher in Tennessee who may or may not have actually taught the theory of evolution. He was recruited to the trial through the ACLU, the American Civil Liberties Union, which was attempting to test a new Tennessee law passed in March of 1925, which was passed partly because legislators said that high school students were coming home and saying that the Bible was not true. And so parents didn't want their children to learn that there was anything wrong with the biblical story of creation. One of the best historical accounts of the Scopes trial has pointed out that this is also the very moment in U.S. history when the proportion of parents who went to high school and the proportion of kids who went to high school was shifting. More children than parents were getting more education. So there are social dimensions, educational dimensions to the Scopes trial. The emphasis is always on the Scopes as a tension over religion and science, but I actually think it was much broader than that, and it was about general social change in the United States at this moment. So in the end, and this was a show trial, there was a lot of publicity. In the end, Scopes was convicted of having taught evolution by natural selection, and he was fined $100. Later, the fee was dropped, and then later it was overturned. But the whole point of the Scopes trial was not this actual legal outcome. It was this public debate about the meanings of evolution. And in the years since then, there have been many other contests. So beginning in the 1970s, there was a movement in the United States called creationism, and the goal of the creationists was to offer creationism equal time in the science classroom. So there was never, for many people, it's fine if you want to teach your children creationism, but the idea that creationism and the Bible should be included in a science, in a biology classroom in a high school was controversial and difficult and actually shot down by the courts eventually. The same thing happened in the 80s with creation science and intelligent design in the 1990s. In the 21st century, it takes the form of what people call intelligent design, and it has a similar goal. The movement has a similar goal that every individual should understand that there are two options, either Darwinian evolution by natural selection or intelligent design. So William Paley still lives. Now, why have these challenges to Darwinian evolution by natural selection persisted even into the 21st century, even after the biological evidence from so many different directions is so powerful, compelling, and unequivocal? I would suggest that it is partly because the theory of evolution by natural selection is in fact upsetting. I'm going to skip that. If evolution does not upset you, you don't understand it. It upset Darwin and his contemporaries, and it still upsets many people today. So my question is, why? And Darwin himself at one point told a friend, if I believe this, it is like confessing a murder, because it is about the brutal elimination of the weak, the young, the sick, or the unlucky. Here's a cartoon about this. I know you miss the Wainwrights, Bobby, but they were weak and stupid people, and that's why we have wolves and other large predators. So is evolution about the elimination of the weak, the powerless? Is it brutal? Is it a terrible story, a depressing story about the existence of life? As his theory stirred up a hornet's nest of philosophical, religious, and scientific critique, Darwin struggled to answer his detractors. He could not describe how heredity worked. He didn't know. He lacked all the modern tools of quantitative population genetics and molecular genomics. He knew nothing of chromosomes or DNA, and it didn't occur to him to count peas. Remember, Darwin never read Mendel. Mendel's paper was published the same year as The Origin of Species, but Darwin didn't read it. And even if he had read it, it's not clear that he would have recognized in Mendelian quantitative population genetics anything that was relevant to his own struggle. So he was ridiculed. He later produced an account of sexual selection and female choice that granted extraordinary thinking skills to female lizards and peahens. And he was not always right. He faced a certain amount. Sometimes he was wrong. He faced, public jokes about him. But his core insight, elaborated across much of his writing, has stood the test of both time and commerce. And I would suggest that no biotech company today can possibly function without an assumption of evolution by natural selection as a guiding biological property. It's also important in medicine, the ways we think about risk, the ways we think about development, the ways we think about all forms of human health. It's the organizing principle of modern biology, and as Dobzhansky observed, and I skipped that quote, nothing in biology makes sense without it. So even the more fanciful forms of modern genomics and marketing genetic genealogy draw on ideas about evolution. So these are three forms of contemporary genomics where you can send in your DNA and you buy some kind of a racial identity, see your genes in a new light, find your roots, Henry Louis Gates, or my favorite, send in your baby's saliva and figure out how the baby is talented. So this is a marketing opportunity built around contemporary genomics and molecular genetics, but also drawing on ideas about evolution. Now, in later life, Darwin believed he had learned nothing in school, nothing from his father, who considered him a very ordinary boy, nothing from 2 universities except that which he learned on his own. He had been, he said, a good-hearted numbskull, astonished and surprised by life. So I will close with an image of both the good-hearted numbskull. This is taken very late in his life, and these were used for visiting cards. You could sell them. They were famous people in Britain would have collections of these cards with their achievements printed on the card, and then with a picture of our ancestor, the gorilla. Thank you very much.
Thank you very much for your informative and very interesting talk. I would like simply to, after, the origin of species back to, 1589 for 150 years, I think now we can just use the legacy and also this theory of, the theory of Darwin to help explain some of persisting questions that still keep until now. The question number one is why those who are already well off feel the need to out-earn others, people until now. And also another question, which is it so hard to abolish poverty in total? We couldn't even, eradicate poverty from the world. And also another question, after 80 years of vote for women and 40 years of feminist revolution, do men still earn longer and better or, larger than incomes than women? And why so many people hate others merely for having different color skins? These questions, they have been approached by different people, by different, by sociologists, by theologians as well, and also by, psychologists also. But the answers were just more descriptive rather than explanatory. They didn't explain as much these questions. So do you think this theory could help explain, these phenomena that they are still until now, these questions that they are still now well explained? Could we use this, theory of which is based on survival and also based on, survival and also the reproduction? So could we just explain these questions by using, I think this theory could help policymakers and decision makers even to find, explanation to these kind of persisting questions. Thank you.
Thank you. They're very important questions about why injustice persists. And evolution and the idea of biological forces causing human behavior has indeed been used to address questions of injustice, questions of racial difference, questions of class. in many volumes on addressing differences between men and women. But in general, the uses to which evolution has been put in that context are not progressive. That is, they are usually used, evolution biology is usually used to prove that people are where they belong. They are biologically, women are biologically inclined to whatever it is, not want to make less. They have a gene for making less. Or groups are biologically violent. So this has been an excuse or a justification for the oppression of groups all over the world in the history of colonialism. So biological, and the problem is, as soon as you talk about evolution, all you're talking about, and I want to make this is a very important point. It's not that the biology has no, human beings biologically have a cultural element. That is, we are capable of language, we learn culture, we have a creative impulse, and that's a species quality. It's a very special species quality. But evolution is only about biology. And the phenomenon that you describe, all that evolution can tell us is about biology. And the minute you start saying poverty is somehow about evolution, you're in dangerous territory. It's actually not a place you want to go. So it's not that evolution tells us nothing about competition between organisms, but I don't think it tells us anything about the kinds of injustice that you're describing, and much of the literature that is only too happy to invoke nature as a justification for inequality draws on evolution in ways that I can't support. So, does it give you an answer? It does, but it gives you an answer that upsets me. What can I say?
Thank you. Good evening. Thank you so much for the talk. Well, you said that one of the things that contributed to Darwin's success is his masculinity. Well, I'd like to spot the light on Darwin's theory of evolution and natural selection, and I'd like to relate it to its social aspect. My question is the following. To what extent does his theory affect gender roles?
There were a couple of observations. I'll start with gender. There's a fairly sophisticated literature now on the impact of a feminist history of science that looks at the ways that women specifically were kept out of virtually all scientific opportunities until even the 1970s. So there really were no opportunities for a woman who was interested in this kind of work. In other words, everything about his opportunity, the fact that he could go for 5 years as gentleman companion on this entirely male mapping ship, was a result of the exact same person born female could not have done that. And there were very few women scientists in the 19th century in Britain, and so in social practice, to be female was to operate as what I call an unreliable knower. In philosophy of science, we look at the ways that different kinds of people come to be understood as reliable witnesses to nature's ways. And usually we're interested in the ways that education and training make it possible for someone to be seen as an authoritative or reliable witness, such that when they say the experiment went this way, you believe them. So trust is a really important part of the process, the scientific enterprise. But there are other ways to be an unreliable witness, and to be female is generally to be an unreliable witness, untrustworthy, non-authoritative for much of the history of science, not an appropriate person to tell stories about nature and how it works. So gender is implicated in his social place and his social experience as somebody who has the automatic right to pursue an understanding of nature and to speak with authority. And that's true for many other roles, so gender is implicated there. The other thread that I want to mention in this context is the idea, and Ingalls was then in Manchester reading Darwin's work and saying it's a perfect replication of the brutal competition of the Industrial Revolution. So it's as though he took the Industrial Revolution and he read it into nature. and it's competitive, violent. Somebody's at the bottom has to die. Only the good survive. The vulnerable can be dispensable. And so, was the theory just politics or economics transposed or read, projected onto the natural world? That's an early critique of the theory of evolution. And then you could, when you get into the later work where he looks at the expression of the emotions and sexual selection, Darwin gets on very shaky ground because he can't explain why the peacock has such a spectacular feather pattern. And the only explanation he can come up with is that peahens are incredibly intelligent and keen observers of slight variations in feather patterns. So he gives females a remarkable amount of power, and even the lowest forms, the lizard, everything that is sexed, females are in fact choosing the species. And it's a problematic conception, and it too reflects Victorian models of male-female relations and the idea that females choose males. And so, but on its own terms, I wouldn't say that the theory is anti-feminist. It's that Darwin and his contemporaries were not thinking in those terms at all. It wasn't a part of the way they thought about the world. So I don't know if I answered your question. I think I kind of got diverted in various directions, but there are a lot of interesting questions about feminism, science, making sense of biology, because female bodies are always seen as inferior in various ways. And you may know that by the late 19th century, there was a reigning theory of a kind of conservation of energy, and a female body that had both a uterus and a mind both couldn't possibly work at the same time. And so that's why women couldn't do intellectual work, because so much energy was being diverted to the uterus. So.
مساء الخير، أنا سأتحدث باللغة العربية إن كان ممكن. أولا جاء في العرض أن التطورية مقبولة عندما تتحدث عن الطبيعة، لكنها تصبح غير مقبولة عندما تضم الإنسان. إذا كانت التطورية هنا مقبولة في المجتمع العلمي أو غالبية المجتمع العلمي، فإنها في المقابل غير مقبولة عند عامة الناس لأسباب دينية غالبا. مثلا في العالم الإسلامي تأييد التطورية هو شيء غير مقبول، وفي بعض الأماكن خطير. أثارني النص الحديث عن التعليم، مادام أنا أشتغل في التعليم، نص الأستاذ الذي تعرض لخطر ما حول تعليم الداروينية في الثانوية. بالنسبة لنا مثلا احنا هنا في المغرب لدينا تعليم مادة الفلسفة، في أحد النصوص يتحدث عن يميل إلى جهة الداروينية في التفسير. هذا النص يعد صعب جدا، استخدم كلمة جيدة أنا، صعب التدريس لأنه يعرض لنوع من الخطر إن شئنا القول. إذن في نظرك هل يمكن تجاوز هذا الحاجز بين المجتمعين، المجتمع العلمي وعامة الناس؟ ثم سؤال ثاني، من ناحية نظرية داروين استخدمت مفهوم مالثوس ومفهوم مالثوس لميكانيزمات عمل الديموغرافيا أو تطور السكان. هل هذا يجعل من نظرية داروين أقل علمية؟ ثم السؤال الثالث، هل الطبيعة تعمل بدون هدف أو غاية؟ إن كانت تشتغل بدون هدف أو غاية، إذن هل تعمل بمعزل عن الإله؟ هل هي نوع من صانع الساعات الأعمى كما يتحدث ريتشارد دوكنز مثلا عندما تتحدث عن تطور العين، وحاول أن يشرح تطور العين من ناحية بيولوجية. إذن هل يعني هذا أن قبول التطورية يعني مباشرة التخلي عن الإله؟ شكرا.
اذا اخترتي واحد سؤال من الاسئله هذا شنو ماشي يكون اختار واحد سؤال
أخير. سؤال أخير.
عودوا
إذا كان تطورية إذا كان القبول بالتطورية هل يعني التخلي عن الإله مباشرة؟ إذن هل هناك تناقض بين النظرية التطورية ووجود الإله؟
Okay, so the main question is, if one were to accept the concept of evolution, would that mean, getting rid of the concept of God? And or otherwise, how does one reconcile the two together?
There have been many thinkers who saw no conflict between evolutionary theory and a belief in a divine order and God. And there have been others who see a conflict. The question might be, the Catholic perspective has been that the making of the body through evolution could be a natural biological process. God intervenes at the moment when the body is ensouled. So God's world is the world of spiritual things, and evolution is the world of bodily things, of physical things. And so the question might be, what is it necessary for the divine order to have produced? And if in order to believe in a divine order, it has to have made the human body, then there's a huge problem. If it doesn't have to have made the human body, if the human body can be an ape's body, if it can be an animal body, then evolution does not pose a problem. But believe me, when you ask that question, you're asking a question that many great thinkers for the last 50 years have been trying to resolve. That is, what is the proper relationship between theories of nature, any theory of nature, and theories of divine order? Any one can be a challenge, even things like cosmology. And so I can't exactly resolve that for you, but I can tell you that it has been taken very seriously by many different scholars for a long time. And for me, the dividing line is that line between embodiment and ensoulment.
The other question he asked, one of the questions he asked is, why is it so difficult for people to teach evolution in Muslim societies? Or, it's very difficult. He said, in fact, it's considered to be dangerous.
Well, I think in some ways it can easily be seen as a very dangerous theory, a very threatening theory, because of that connection between embodiment, identity, and existence. So your body is yourself, and if you think your body is the result of something that has nothing to do with divine order. William Paley's portrait of the world is a portrait where human beings, are the purpose of the world. The reason the world is here is that God wanted human beings here. And everything in Paley's world is built around, in a very benevolent and charming way, built around the needs of human beings. Chicken tastes good because it's good for people. So it's this happy world of order and purpose and meaning. And evolution by natural selection, in ways that are genuinely disturbing, makes the world not built for human beings. Human beings aren't even necessarily, the apex of evolution. They may not even be the best creatures on the planet. So is it worth knowing and understanding? Yes, it is. Does it threaten certain kinds of worldviews that are oriented around human beings as the most important creatures on the planet, and also as very close to God? Humans are godlike in much religious thinking. If their bodies, their minds are the result of this process, which doesn't sound all that charming, then then who are they? What are they? I mean, it is a fundamental theory, and I don't know how to teach it in Muslim society because I don't have any idea. I know that even in the United States, in basically a Christian society, it has been controversial for its entire history. And occasionally I ask my students at the University of Pennsylvania, did anyone teach you evolution in high school? And they say no. So it is still banned in some high schools. It is still understood to pose a challenge to religious worldviews. And I'm not sure that I can't make that challenge. That may be a valid challenge. How do you see the world? Why are we here? What does evolution tell us? It's kind of a depressing story.
مرحبا. هناك كتاب عربي بعنوان آذان الأنعام لكاتب بريطاني من أصل سوداني. هذا الكتاب يحاول أن يمزج بين نظرية داروين وبين القرآن الكريم، وهو يمزج بينهما عن طريق العثور على الحلقة المفقودة التي لم يجدها داروين، والتي يعتبرها الكاتب هي لحظة نفخ الروح في سيدنا آدم. بخصوص هذه الجزئية، هل لدى الدكتورة اطلاع عليها؟ وإن لم يكن، هل قامت ببحث من أجل المزج بين أفكار داروين وما يعتقده الإسلام أو القرآن في هذه النقطة بالضبط، لأن القرآن يفصل فيها ويعطيها أهمية كبرى. وشكرا جزيلا.
He said there's a Sudanese scholar who wrote a book on trying to connect. There's a missing link between what Islam says and what Darwin says. If you're aware of this kind of writing, and furthermore, but the most important question would be, are you aware of any connection between Islam and the notion of evolution and some kind of missing link or the way they can be connected?
I'm not, because I don't know what Islam's theories of the origins of life are, so I'm an ignorant person to ask. And I mean, the key thing about Darwin is it's a theory about where life comes from and how the biological world is organized. And my guess is he was drawing on many threads of thought. I don't think Islam was there. I think industrialization was, Christianity. I don't think he had read any Islamic thought. So in terms of his ideas, probably not. Has it been done in the present? Apparently so, yeah.
Hi, thank you for the presentation. I had a question. I've kind of always wondered this when it came to evolution and like that part of science. Like, could you talk about, I guess, the connection between evolution and like the history of it and also the eugenics movement? And like how, like the sterilization of women and like how a lot of people like scientifically thought that like people of color, as black people specifically, were deemed to be like criminals, like because of I guess like for like biological reasons, and just like the connection between that. Thank you.
Darwin's cousin Francis Galton was the thinker who, in a book called Hereditary Genius, published in 1881, when is Hereditary Genius? I don't know, but it's the late 19th century. In Hereditary Genius, Galton said that all great families were great because of biology. So he did a long lineage of all these great families and all these high-achieving individuals. Everybody Galton identified as a genius was male. Even if you were from a great family. And what Galton proposed was that if any society was willing to accept the idea that it was important to breed cattle to get better cattle or to breed racehorses, an enlightened society should also start breeding genius, controlling to breed for genius. So only the best people of any generation should be permitted to reproduce for the next generation, because that's what you do with cattle. I'm making it a little bit more crude than it was in Galton's thought, but that was the basic idea. Now, you have to, so it became, and he came up with the word eugenics. Eugenics was, there were many books before Galton that said things like, if you want to have a beautiful baby, find a beautiful wife. You want to have a smart baby, find a smart husband. So the idea, everybody knew in a kind of like begets like way, they knew that people had children who were like them. And you should therefore find a spouse who had those qualities that you most wanted to see in your children. But what Galton was proposing was a systematic and planned effort to control human reproduction. The strange thing about eugenics is that eugenics was adopted basically all over the world. There were eugenics movements all over Latin America, in Britain, all over Europe. In Africa, there were Jewish eugenics movements. There were feminist eugenics movements that said we can never know who the best women are until women have full equal rights. And so we've got to let them have equal rights, and then the ones who really succeed can be the mothers of the next generation. So there were all kinds of ways that eugenics as an idea, and the core idea is that any society should undertake a plan to control who will be the parents of the next generation. That's the core idea. So controlled reproduction from the perspective of planning and through a series of laws, oppressive, involuntary sterilization, many kinds of measures that were intended to control who that next generation would be. The eugenics movement was thriving in the United States, and a series of involuntary sterilization laws were passed, but it was actually thriving in so many other places, and we now know this very broad history. It led, or it is the parent idea that leads to Nazi racial hygiene and to the idea that you shouldn't just prevent certain people from reproducing, you should kill them. So it leads to genocide. Most people think that there are still threads of eugenics floating around that have to do with perfect babies, with the selection you might make in terms of reproduction, with all the genetic testing or the testing that permits individuals, for example, to choose whether to give birth to a boy or a girl, or whether to bear a child to fruition who has some sort of a disability or some sort of a genetic problem. So there's even a contemporary 21st century debate about what eugenics is. It's interesting that eugenics in different countries involved very different policies. So in Brazil, the policy was as many different races as possible should breed together in a big mix, and that will lead us back to the Greeks. So the idea was that somehow more racial admixture would produce a population, a race of the finest Greeks of ancient history. In the United States, the eugenics movement was heavily oriented around what proponents called white trash. So the eugenics movement in the US was less racialized than it was in some places because the threat of, you can find, it's almost as though people who were not white were not even seen as a part of the future. They didn't even matter enough to control their reproduction. And so you can find all these books about white trash and about you need to control the hillbillies, they need to be sterilized, but you don't see much about African Americans, you don't see much about Hispanic Americans, except in a few isolated cases. So race means different things in different eugenics movements, and in Britain, the eugenics movement was very oriented around class. So the upper classes should reproduce more than others. But there's a sort of an accusatory literature that says Darwin leads to Auschwitz. That is, Darwinian evolution by natural selection, you can draw a straight line to genocide through Darwin. And most historians who've looked critically at the levels of thinking and at Darwin himself don't believe that. If you phrase the question a bit more modestly and you say, did ideas about racial difference play a role in evolutionary theory? Yes. Did they play a role in eugenics and eventually in the Holocaust? Yes. But it's not a simple line from Darwinian theory to the sort of racial hatreds that were animated even by these eugenics movements. And I want to emphasize that I use a single word for these movements, but they bear almost no similarity. They differ so much from country to country and over time in terms of policies, practices, goals, the ways they thought about how to achieve that goal, that the only thing that cobbles them together in a kind of awkward way is the idea that human reproduction needs to be controlled.
Thank you, Professor, for your lecture. I just believe that the first step in discussing evolution is to fully understand it. And one of its main conclusions is still mind-boggling to me, is the fact that we say that men come from apes, or men and apes at least, they have the same origins, which is a change of kind, a change of species,
Right.
not a bodily change. So, Professor, can you give me an example of a change of kind throughout history?
Not in recorded history, unless you want to say something like the moth example, which is used so commonly, the peppered moth and industrial melanism, which they call that. We do know, for example, one common example that's given is, and there that's not exactly a change to a different species, that's just a change as a result of selection pressure. A common example of a change from selection pressure is the very rapid rise of antibiotic resistance. So many kinds of bacteria have become resistant to antibiotics because of the selection pressure of antibiotics, so that if you kill off the whole population, the few that can make it manage to become the progenitors of the next generation. You're asking, can we see in recorded historic time a complete change from one type of organism to another? And we can't. We can't see it. It's not enough time. We need Lyell's deep time, and we need minuscule, tiny changes over incredible time periods that are really, in some ways, kind of hard for us to imagine. So in some ways, you have to take these, you have to say, by analogy, we know that organisms can change quite a bit in historical time, and they have changed quite a bit. I don't know how many of you like, if you like dogs, you know how many breeds of dogs have been developed. They're all from the same type of dog, and dogs have acquired every kind of behavior, appearance, hairlessness, size, so huge variation. They're all the same dog, but they look very different. Yeah. They're still dogs. So what you have to do is you have to move by analogy. You have to say, we know this happens in historical time, and if you expand the amount of time you have to consider it, and you take all these other kinds of evidence together, including fossil evidence, geographical evidence, and so on, can you believe that this is how the process worked? But if your question is, can we see it in real time from a dog to something entirely different? No, we've never seen it. We can't. Well, usually the way people describe that is more now, I mean, Darwin was working with a kind of analogy, but people describe that more now in terms of fairly precise DNA mutation trails. So you know how much DNA a gorilla and a man have in common. And you can sometimes see in something like, I don't know how many of you know any genetics, so I don't want to lose you all, but you can see in, say, a gene with 30,000 base pairs that is shared between gorillas and humans. That's what's called conserved. It's conserved across species. It has 30,000 base pairs, and a single substitution in that giant gene produces a different metabolic outcome. So that humans and gorillas might differ in this one key point of metabolism, but the difference is the result of something relatively simple to happen in DNA. DNA, that is, a base pair substitution, can happen for a whole bunch of reasons. So the DNA evidence, even if you want to say we can't see the morphology, we can read today in the DNA relationships between tulips and boysenberries, and between human beings and even, ducks or daffodils. That is, we can look at changes in DNA and see what is conserved or what's in common and what's different, and we can find incredibly minute and detailed differences between different species, but those differences also suggest historical relationships. Now, the way to refute that is to say, you could say DNA doesn't tell us anything. That DNA, even, if you wish to take a divine perspective, you could say God put the DNA there, and the fact that it varies doesn't tell us about a historical relationship. But that's very powerful evidence in favor of the capacity of a single relatively minor shift in the DNA producing a very dramatic change. And I'll mention one more thing, and I don't know if you know of the people who began to be described in the scientific literature in the 19th century as wolf children. I don't mean the children who were supposedly raised by wolves. I mean children who were born with a complete coat of fur, like a dog. It doesn't happen very often, but it is in the genetics literature that occasionally someone is born as a result of a single gene being switched. They're born with a fur coat. And so how much, what they taught us, what they teach us, is that it is possible to move from the peculiar status we have, the naked ape. Remember, we're the only mammals with the strange hair patterns that we have. That we can move from this pattern in a so-called reversion to an earlier pattern of being completely covered in hair through some otherwise healthy, these kids are otherwise healthy, through some relatively simple mechanism. So how do things change? They can change, first of all, we can see the historical relationships, and second, we know that fairly dramatic morphological, or what we call phenotypic changes, can be the result of a single substitution, a single DNA change, which means you can do a lot with a relatively minor, in terms of morphology, with relatively minor changes.
Thank you for the great lecture. So my question is, do you think that Darwin's theory, the survival of the fittest, could be a product of its time? So I'm looking at it from an historical, societal perspective. And would Darwin have shifted his theory if he had witnessed maybe socialist ideas in the 20th century? And like if he looked at, like solidarity between the weak and the strong, if he had analyzed, I think that maybe this was not something that was predominant of his time. And also just generally human beings' dependence on collaboration. This is more from a sociological perspective, but it would be great to have your input.
He did think about human social order explicitly through his studies of emotions. So Darwin, he's enjoying a bit of renewed interest now for his work on human emotion and the power of emotion to shape social relationships and social bonds. Darwin knew that social bonds were important for human society. He knew that. He observed it in all the places he went. And so when he wrote about the expression of the emotions in man and animals, he believed that there were certain core emotions that all living beings, including things like cats and rats, had in common with human beings. And on this, he's been critiqued for this reason, but he certainly did understand that the social order mattered. Now, you started with survival of the fittest, and survival of the fittest is not a particularly warm and fuzzy collaborative model of human society. It's kind of a brutal model of human society. So what he had to do was to think about the possibility that collaboration or that working with people was an survival advantage in human populations, that it made it easier for them to survive. But survival of the fittest means that somebody's not fit and they die. So I kind of don't entirely know how to answer your questions. Did he see it? There's a later literature, very detailed literature about the social implications of survival of the fittest and what it means for society, what it means for the way you should organize a society. But Darwin himself in the 19th century is not quite so, that's no longer his world. These are people drawing on evolutionary theory. And evolutionary theory can be used to say the poor deserve what they have. Those at the bottom deserve to be at the bottom. People land where they deserve to be because it's a dog-eat-dog world, or it's a capitalist world, and success is evidence of biological superiority. So it can be a kind of a dangerous thing to say.
Hi. When speaking about the worsening environmental issues going on today and climate change, we often hear about different plant and animal species that are seeing populations affected. But what ways, if any, do you think human evolution will be affected in the next 100, 200 years if these conditions keep worsening and declining?
You know, you raise an interesting question, and it's important to realize that human evolution, we're still evolving. Human evolution it's not on a kind of clock. And all it means, evolution is just a way of describing the fact that circumstances dictate which individuals in any population are more likely to leave more progeny. If you want to be a success at evolution, you should have a lot of children. So if we turn your question the other way and we ask, how are social and political forces encouraging more reproduction in certain kinds of people and less in others? And is that the key? Well, then that's a different question. So where are families larger in the world? Those are, in terms of Darwinian evolution, those are the successful places. And where family size is shrinking, or perhaps survival to adulthood is a better parameter, then in those places, or those individuals who never have a child, those are evolutionary dead ends. We can't, in 200 years, we're not going to see anything too dramatic. That's only about 6 or 7 generations. And remember, deep time, you're just not going to see anything like that affecting human beings unless there were what we would call some sort of a dramatic bottleneck or a population crash. So if the population were to crash and the number of people who survived was relatively small, that would have a dramatic impact on the future of the human species. But barring that and continuing the complexity of the way that reproduction happens in the world today, one of the things anthropologists say is that two human groups never come into contact without exchanging genes. And so basically everywhere around the world, all the isolation that at one time seemed to indicate purity or pure lines, that has been eliminated. It's gone. People fly all over. They have all kinds of relationships. And we really are a very mixed species now, mixed populations, and probably pretty sturdy, perfectly capable of surviving. In terms of evolution, climate change is horrible beyond belief, and the environmental consequences are tragic. But if the question is, will human beings as a species survive? Probably, yeah.
Okay, with this optimistic note, we'll conclude our event. Thank you so much. Let's go out for the reception.
Thank you.